I'm delighted to introduce Ulrich Trog, who is Innovation, Marketing and Business Development at Joanneum Research. And as you can see, he will introduce Supresil, increase pot life of your silicones. I hope I pronounced this correctly, Ulrich. If not,
Perfect.
please correct me. And with that, we can hear you, we can see you, slides look beautiful. The stage is yours.
Thank you very much, Christoph. Yeah, welcome everybody. Today I'd like to talk about silicones, and for those people who work with silicones, you do know that pot life is limited. So what we do is we increase the pot life, and this is something I'd like to show you a little bit more about. So what you will hear, what I'm going through today, where are silicones usually used, what are the limitations, and we call it a reversible inhibition. What does that mean? And how does that work, that we can actually guarantee you shelf stable silicones. Then I go into a bit more depths about general conditions for the application. So where does it work? Where does it not work? I show you applications that we have tried, where we've done use cases, where we've worked with customers, and I give you a new use case that we are just working on at the moment, which is the digital printing of silicones, so printing through inkjet. And then in the very end, how we operate or how we cooperate with interested customers. So for most of you, you've been in contact with silicones. Obviously, you know them from your classic bathroom seals. So they're used widely in construction industry. You know them from cooking utensils. You know them from medical implants. For the academic people, they, like in the labs, work with PDMS to make stamps and imprint very fine structures. So it's a very wide use that silicones are spread over. Now, what is the problem? Like with silicones, you usually have two components. You have a component A, you've got a component B, and when you start using them, when you start processing them, you put those two components together, you mix them, and from then on, the reaction starts. So the curing starts until, and that could be at temperatures, higher temperatures, lower temperatures, whichever way. But usually you've got a gel time and then it's cured. So you've got a pretty short time where you can actually process your material. And so the practical and technological constraints that we know from customers, it's number one, a short processing time. So meaning could be an hour, could be 2 hours, could be 3 hours, but it is limited. That causes a manufacturing waste. So whatever you cannot use in the process, you've got to throw away because you can't use it. Now, with that curing already started as soon as you start mixing the two components, that also means while you process your material, the behavior changes. So it's difficult to reproduce or have a reproducible process, which makes it an inflexible process. And we've also got requests about, can we work with low temperature processing? So this is also something that doesn't always work very easy. So these are the limitations. And our proposal is a reversible inhibition of the curing the hydrosylation, so to make shelf stable silicones. That means when we completely inhibit the curing, so I should say, first you mix the two parts together, and then we inhibit the curing. So you become a storable mixture that you could put on the shelf, and when you then need it in your process, you take it out, you don't have to mix it again, you start processing it. We do that with volatiles inhibitors, so they are within your mix. Then when you start processing, they